In modern physics, we usually use something called general relativity for dealing with gravity. It states that there's this field called spacetime, and when massive things interact with it, the field distorts and causes other objects to fall around it, just like how the Earth distorts spacetime, and thus causes the Moon to orbit.
One problem with general relativity is that it can't be applied to the atomic or quantum scales.
Here is the standard model. What you're seeing here are elementary particles. If you look over here, you'll see these 4-gauge bosons. These are what we call the carriers of fundamental forces. There are 4 fundamental forces. The photon carries the electromagnetic force, the gluon carries the strong nuclear force, the Z boson carries the weak nuclear force, and the W boson, it also carries the weak nuclear force. The problem with gravity is we haven't detected a boson that has the ability to be its force carrier. String theory suggests that reality is made of these strings that vibrate. You can think of it like a violin. When tuned at certain frequencies, a violin's strings produce different sounds. This is similar to how when a quantum string vibrates, they become different particles. In one certain case, a hypothetical particle comes out if you vibrate the string at a certain frequency, and this particle is called a graviton.
The graviton supposedly carries the gravitational force. So that's it, right? It's solid. Well, not really.
First of all, some string theories need more than the 3 spatial dimensions we're used to, and some even go as far as 11. Second, string theory doesn't offer any ways to get rid of the extra dimensions. The closest thing we have is saying that they do actually exist, but they're just too small to see.
There are, however, other proposed solutions to quantum gravity other than string theory.
Loop quantum gravity suggests that spacetime is quantized. Like this video here, if you zoom in far enough, you'll find that it's made of pixels. That's what spacetime is like according to loop quantum gravity. Here are loops. You can say they are the pixels of reality. Loop quantum gravity states that space is defined by how these loops are shaped, and time is defined by how they move. This is called a spin network because it's related to a certain property of particles called spin.
So whenever something interacts with the spin network, it gets distorted. And since the spin network defines space and time gets distorted as well. So, that's quantum gravity, one of the biggest mysteries physicists are facing today.